Hello students, my name is Sumit Sagar Hota, PMRI PhD. Today we will discuss lecture 5 of the live discussion which will conduct theory. Here it the problems are taken introduction to combustion concept. What distinguishes laminar non-premixed flame from premixed flame? Actually, this are non the answer to this question. Fuel and oxidizer do not fully the combustion of your non-premixed. Okay. The basic difference between the laminar non how the fuel and oxidizer non-premixed flame fuel and the what distinguishes laminar non-premixed and the premixed that fuel and oxidizer for and non-premixed where does takes place. So the person take place at the not in the environment. There is well mixed environment means okay. There is a well mixed environment is there, that means a pre-mixed. Okay, this is yes a turbulent zone. Okay, not specific it's turbulent or laminar because it's given in laminar. Okay, cannot be in homogeneous mix. Not deal with the homogeneous or heterogeneous. This is now the left is that interface between What is the primary factor influencing the flame structure in laminar non-premixed? Okay, so these are all factor. Turbulence is a factor, temperature is also a factor, pressure is also a factor, but heating rate is the important factor. How the fuel and oxidization depending upon that the flame structure. Laminar. Which of the following is a characteristics of laminar non? The laminar non-premixed given. Turbulent combustion cannot be an option. Rapid mixing before combustion. Before combustion means it's a premixed flame. Option. Separation of fuel and oxygen. Okay, we go to that. Uniform temperature distribution. Okay, in laminar flame, laminar non-premixed flame, uniform temperature distribution may be a case, but not always. Okay, it cannot be also. So the separation of fuel and oxygen is only the option. What is the role of diffusion in laminar non-premixed flames? Premixed. Diffusion never enhances turbulence. Okay. Diffusion never accelerates combustion because combustion depends upon the what, how the mixing thing, but reduces the flame stability. It does not have any effect on flame stability. Okay, but it can facilitate the mixing, and because of this mixing rate, all these accelerates combustion, enhance turbulence, and not enhanced turbulence. Yeah, turbulence also can be an variation in velocities and velocity profiles. So because of because what is the question is what is the role of diffusion in the laminar not mixed? Okay, so only facilitates the mixing, and because of mixing, this acceleration of combustion is there, and when the combustion accelerates, it reduces the flame instabilities. Okay, become stable. Cut the whole. There is facilitates facilitates let's a laminar non-premixed flame which zone is typically found adjacent to the fuel source. Now if you see in this question, okay, oxidation zone, then reaction and preheat. Okay, fuel source. What we need, which charges and fuel source. Fuel source cannot be nearer to the oxidizer. Okay, it cannot be nearer to the oxidation zone cannot be nearer. Okay, first wrong. Now post flame zone. Post flame. Okay, first the fuel will be there, then the oxidizer will react with that, and after that flame formation is there. After the flame formation, that is a flame post flame zone is there. 100% wrong. Then reaction. Okay, when there will be oxidizer, there will be what, fuel, and only there whatever the will the reaction form. Okay, so the reaction zone cannot be nearer your what, laminar non-premix fuel source. The laminar non-premix. Okay, wrong. Okay. Now one thing left is free heat. Sorry, tension and doing thing. Okay, next question. What happens to the flame speed as the laminar non-premix? We know balance rest. First the proportional flame speed. The flame, the flame speed as the equivalent. If this will increase, obviously, but the answer is B. Now next question. What parameter characterizes a a thing on pre is a very good. They are telling remixing in a non-premix. We know there cannot be premix. Remixing. The Lewis number is your alpha I at mass. One more way of deriving Lewis number is Lewis number is equal to Kim's number divided by Prandtl. This number is by D Prandtl mu by alpha. What is so? What is nu by rho? K by rho Cp. T तो already you know mass diffusion. 2A mass of Lewis number. To the next. Which of the following is true regarding the flame stability non-premixed flame? Let's remember. So now here you see which of the following is true stability. Flame stability premixed. इसलिए higher turbulence is never going to increase the stability. Obviously decrease the stability. Higher turbulence decrease the stability. This is wrong. So okay, next one. Flame stability is unaffected by mixing rate. Okay, obviously it depends on the mix, because if the mixing is very good or mixing is very lean, depending upon that the stability can be affected. The mixing is very much rich, okay, and there is less amount of oxidizer, the flame stability can be very well affected and there will be a flame extinction. Okay, so that is this is cannot be option, this is also cannot be option. High Lewis number promotes stability. Okay, Lewis number, always remember Lewis number 99% of case we take equal to 1. Okay, there is no high or low concept in of the Lewis number. Okay, so for the laminar flame, non-premixed flame, most 99% of case we take Lewis 1. Okay, or sometimes it can be taken as less than 1. Okay, cannot be more than 1. Okay, maybe in turbulent case you can expect greater than 1, all these things. Okay, high Lewis number, that is a wrong option. Oh, okay, this is also a wrong option. One option left, the low equivalence ratio, not very low. Okay, it's actually the question means that slightly low. Okay, you can tell slight low. Okay. Slight low improves the see the peak temperature. Okay, slightly, if you see, that's not the case. So it's slightly less equivalence ratio. Let's go to the last MCQ. Then we go to what is the primary factor in characteristics of laminar non-premixed ignition. in the having different of auto ignition temperature. Okay, their auto ignition temperatures are different for different quantity. Sorry, different types of for the laminar non-premix. To find out the primary factors. So, ignition characteristic can be affected by turbulence, but it's not a primary factor. It can be affected by flame length. Okay, what is the flame's length? Okay, when there is combustion is occurring, what is the flame length? How means what is the height of the flame from the inlet? Okay, all these things also matter, but it's not a major factor. After combustion only this thing will take into a consideration. Okay, they're not the major characteristic for the ignition. Temperature is obviously the obviously there is a factor. Okay, there is ignition means obviously it depends on the temperature, okay? But it depends purely on what ignition characteristics for the laminar premix time. Major factor is the residence time, okay, which is the what inverse of the mass flow line structure mass. Okay, the very important factor. Okay, write down let it when time tau r is equal to r. Star your structure mass mean mass flow rate second. Mass r. I am telling structure tell you. So you know in a system, okay, this is your system. Okay, so where all the reactions are taking place and surrounding the system only, we are assuming that in the system only all the reactions are taking place. So what we do in the system, will take the all the meshes, okay, as the fine structures here. Okay, so that our we can very easily capture the reaction mechanisms. That's what the is here surrounding, and this is your different way. Authors having way of explaining how are is your yes, the fraction f, so that equation 9.44 is correct. 9.4 I will write. This is for taken from the book. Other things. YF stoichiometry divided by 1 minus F equation 9.44a. Okay. No, for this YF, okay, abstraction for the full F stoichiometric is always less than F is always less than. Okay, this is the condition for what inside the flame. F will be well. For solution part, definition of F that will prove. You know what F is equal to YF 1 by plus 1 by a product. Okay, how this 1 kg well is there, gamma kg acts, then gives 1 plus gamma. What is this? F stoichiometry 1 by gamma plus 1. 1 kg of fuel divided by plus gamma product. F stoichiometric. Now we know that summation of what T, sum of the one. So y of product is equal to 1 minus y of fuel. So now we substitute in, so F YF plus Fs, what is y product 1 minus, rearrange, take YF common, 1 minus Fs plus Fs equal to F. Now Ef, find out F minus F divided by 1 minus F. You see, this is what your equation 9.44a that we now proved. A circular port and a square port burner operates and Okay. A circular and square part one operator with the same. It is circular portlet represented by C. Okay. F is flame length, port flame square flame. Mean velocity flame length. To find D by B. Okay. Circular port diameter and B will be your length of side airport. Type of question actually formula. Guess it the end itself is the flame length. So we should know the formula for the set. If you know, then you can very easily solve this. So let's start with put some assumptions. Only one assumption. Formula as the for person's name per purpose correlation. Result infinity same go to solution. The QF that's for your circular body E I by 4 D square is your LF C 1330. The formula is infinity by D F capital F. capital F for the fuel, small f for the flame. Ln 1 plus 1 by S. Yes, S is 4.76 times. Why I tell you? Because the formula is same for both circular and formula is different. In one kind of question can be asked in exam. Okay, can either ask square or they can either ask formula. Formula for the put is the fuel flow rate for the square is equal to V square. Okay. F one zero four pi infinity by inverse of F 1 plus F power 0.5 whole square. Exam. Okay. I directly not terms of Q F directly write down V into V square. What we do? Basically, we will equate both. LF square is circular L to LF square. So here if you see here D is there, here B square and B square is there. Okay, just take D and B to the left hand side and whatever's there just put it in the right hand side and take the square root. Okay, here is the fuel. Fuel is the methane. If the fuel is the methane, then S is equal to 4.76 times A, and A obviously you know x plus y by x y equal to h 4. So x is equal to 1, y is equal to 4. 1 plus 4 by 4 to 2. 4.76 into 2 equal to 9.52. We do substitute the s. E by b is equal to 4 save 0.308. Out this in 0.308. Okay, very simple. Search table 9.4 page 338 of the book SR turn. Hertz of f 0.30, hertz of ERF error function omega 0.308 and value will be but 0.28. This is taken from the table. Okay, this okay. So now d by b is equal to 0.1002 0.28 get we solve 1.13 will be here. Okay. Is directly this much big question they won't ask. They will ask you the question. They can ask you directly what is the flame length of the circular port or the flame length of the square port. Okay, they can ask you error function related question. Ask. Okay, you t infinity everything they will give. Okay, and then they will tell you, okay, things are given, then find out your flame length, or they will tell you find out V as your question very easily. Of all these questions that I think are for short question, very problems related question. The question ab but the both are interesting. So of the moment think you should remember when B to BE bar given. Sometimes we called it as top hat profiles. Yes. Okay. They want such question. Top hat profiles. BE is equal to BE bar. This to is your parabolic profile. What we find ratio of AE 2 by all are R base assumptions we can put properties depends on the stage manner. Bar some impurities or into go to the solution. Dot in m dot rho B A. Okay, m dot is equal to rho B A. We know, so bar in A into what is A, cross sectional area of the circular port. Okay, higher write down 1 is equal to rho B by R. This is your first one. Now let's go to the second case. Basically, for finding area for a variable port, what we can do, the variable velocity profile based port, circular port, can do is that we have to take the integration. So the upper limit obviously are rho A B. That's what we did. E and minus write down in terms of this. Easy for integration. This is what the profile 2 pi r dr. this 2 pi r d is your perimeter. The circular port. So there. Okay. What we do now? Just take all the constant terms outside of the integration, then integrate. 4b here. Actually. Okay. So 4 v square rho into pi divided by r to the power 4. Okay, because in integration is r to the power 4 by 4. 4 is just take to the. Okay, so one more 2 is there, that is inside. 2r pi inside 2rd substitution. U is equal to capital R square minus small r square, guys. Du is equal to minus 2r. Now the integration limit will be changed. At r is equal to 0, u is equal to what? R square. R is equal to capital R equal to 0. Change everything. 4 pi d square by r to the power 4 square to 0. To 4 pi rho v square to the power 4. Change the limit by because of what? Negative sign. Can have the power to change the limit. Okay. Square d integral v square 3r to the power 4 to r square integration u 3 just taken outside, and then it to r to the power 4, sorry, at r square, and substitute 4 pi rho ve square by 3 r to the power 4 r square cube minus. So now substitute here, r to the power 4 is there, here r to the power 6 is there, that means r square will be there in your. Okay. AE2 is equal to 4 by 3 I r. Now what do you use? The ratio. JE2 by JE is equal to 4 by 3 V square pi divided by rho V square square, rho v square pi r square. Solve. This term will get cancelled. So it will be 4 j2 by j1 is equal to 4 by 3. No question you can expect. Okay. So instead of this much big velocity profile, they can give you one velocity profile. They can ask, or directly one give you the values of different types of velocity profiles like cubic or all these things, and they can ask you to find out the momentum flow. Okay, those questions can be expected. Let's go to the next one. How does the coefficient? What is the things? Ropers. When invented automation assume it has 3. Else given equation 9.6 also given. 9.6 f experimental is equal to 1 3 f t infinity by t f on 1 plus 1 by Okay, so what is the equation to find T infinity? This thing will have theoretical flame length 0.59, which is infinity by T. Equation they will give in here because equation very difficult to remember, but possible, so that because if they don't ask you the question, they can ask, okay, the theoretical flame length is inversely proportional to your diffusion coefficient, true or false. Don't know the formula, obviously you can't answer. Try to remember if possible. Power 0.6. What is the assumption? What are your assumptions given na? You're in the assumption. Okay. First, second will be experimental and theoretical flame lengths are equal. That means we are telling LF experimental equal to LF theoretical. So now you will obviously know what will be our next step. We will equate the both flame lengths. F So if you don't know these two formulas, then how you can things are the reason why you need to remember this formula. Otherwise, no results of D, which is expressions. However, Q for pi D infinity on 1 plus 1 by infinity by 0.67. Other things we cancelled. QF get cancelled. D infinity by TF ln 1 by S ln 1 by S. If you find out T infinity by 4 pi 1330 T infinity by TF power 0.67. Substitute T infinity and TF 1 by 4 pi 1330 300 TF 1500 0.67. What you do? Solve it. we solve, we will get d infinity as 2.035 to the power minus 5. What is the unit of t diffusion coefficient? Question: what is the unit of diffusion coefficient? Yes, you can confuse with meter square per second, meter per second square, meter square per second square. There they can confuse. Is equivalent to t equivalent to t of diffusion coefficient 0.1 into 10 to the power minus meter course or what, nearly same values. In the question, if you see, they asked, but how does the value compare with the value of the binary diffusivity of oxygen in air at 298 Kelvin? Okay, oxygen in air at 298 Kelvin, they have given this value 2.1 into 10 to the power minus, and here also again we find out these values, and the value which comes out to be same. That means whatever the diffusion coefficient at the infinite means at the atmospheric condition same as here, but here but same as here oxygen air. Okay, that's that. Because of that, nitrogen is in estimate and the and whatever. Let's quickly go through it. Dilute mix, whatever, dilute mixture or dilution. Oxygen and air already are diluted. in one statement you can tell, say, simply where the oxygen in air also oxygen is there. So Louis, what we need to find Louis number and Ski's number. What are the assumptions we can take? CO2 of air is equal to 2.1 10 to the power minus 5 meter square per second. Alpha and nu are same with a dilute mixture of O2 in air at 298 in from the book, that is alpha of air is 22 point into 10 to the power minus 6 thermal per second. Nu of air, kinematic viscosity of air, 15.89 into 10 to the power minus 6 meters square per second. Appendix. So Lewis number alpha by d we know 2.5 10 to the power minus 21 into 10 to the slightly you obviously know, but this laminar kind of flame is obviously I already told Lewis number is always 1 or near to 1 or sometimes less. Or non-premixed flame, actually you can find out scheme number as mu by d 15.89. This kind of question very easily asked in your exam. They just given all these values alpha nu all this thing, okay, then they will ask you what is the value of Lewis number and what is the value of scheme number, Prandtl number, all these kinds of. Okay. For one we can is equal to 1 reasonable assumption for the case, but we cannot comment anything on schemes number. Okay, one more we can try. Big question is very simple. along center. Desire to locate center as a however meet of the states at and the being a constant line, the axial for a non-reacting rate Reynolds of that summary purely rate radius. So given P is equal to an atmosphere, Tf is equal to T air equal to 300 Kelvin, Cp is equal to 1087 joule per kg Kelvin. Same maximum temperature 1200 Kelvin. REJ jet Reynolds number, diameter jet radius 1 mm. Two bits F at F1200 Kelvin. Okay, F at 1200 Kelvin we need to find out the flux. And the axial distance along the central line. Here. Hence, along the center line. Okay. Now, what are the assumptions? Simplified state relationship. The basic assumption, all things are simplified. Means there will be no change of state time. All these things. Start with the A bit. As a function of f is equal to okay, so f in delta SC divided by C plus F at infinite also rounding Tx Ox infinite. So what is delta H? Equal to 5016 kilojoule per kg, equal to your lower heating value of what? Whatever from appendix. What we do? Rearrange and find out F, small f. E of F minus deoxidizer infinite delta SC by C plus EF infinite minus TOX infinite. Okay, here in this question there is actually, you can write down also infinite. Okay, here in this question there is no temperature of the air. TF and TAR are same. Okay, even in the question if you see, the system operates at 1 atmospheric and the air and fuel enters at 300 Kelvin. Okay, so all are 300 Kelvin, fuel and air. If infinite is equal to OX, infinite is equal to 100 Kelvin, then substitute the values. Then 1200 minus 100, 5016 by 1.07 kilo kg Kelvin per kg Kelvin. Now if you solve, you will get F as 0.0196 1200. Next part, you need to find out axial distance x. Okay, one formula by FO, okay, equal to 0.375 REJ x by R inverse. Okay, and now what is this IFO, YFO? This is a small f. For what? Why YFO on this thing? When this thing a non-reacting photon. Okay, in your exam I can ask you one question: when this fuel mass fraction and your small f mixture fraction will be same. Okay, when there is a condition for non-reacting jet. Okay, the jet cannot react easily, then there is no use of what. Okay, things will same on jet. What will be? We already have the small f value. Just find out x. 0.375 is capital R divided by small f. Answer 0.375 in 30 is your Reynolds number of the jet. Small r is 1 mm, that is 0.001 divided by small f already given 0.0196. Solve it, you can find 0.57. Kind of, yeah, x can be asked. It's also very, they're very expected question. Yeah, and then ask for the attending the sex related